6. You have a summer intern position, blah, blah, blah. Protons exit the machine. So number 56. Velocity equals 2 times 10 to the 6 meters per second. You've been asked to design a device to stop the protons safely. You know that protons will embed themselves in a metal target. The protons are traveling at, so Vmax, Vmax is 2 times 10 to the 5th meters per second. That's going to emit an X-ray. I don't know if it's Vmax, but let's call that Vx-ray. We decide to slow the protons to an acceptable speed, then let them hit a target. 2 metal plates spaced at 2 centimeters apart and drill a hole. So, that's 2 centimeters. Take paleo to the next level. Okay. What are the minimum surface charge densities you need on each plate? On which plate, positive or negative, faces the incoming proton beam? And what happens if you charge the plates? Okay. So let's see. We charge the plates to 1 times 10 to the minus 5 coulombs per square meter. Does the device still work? All right. So to get it to work, what do we have to do? All right. So we have to use that equation. Right. We know that that this is the electric field, and we're going to need to stop it. Do you remember what N stands for? Yeah, it's this says Q, but this is actually N. Does everyone see that? Because it's coulombs per square meter. So this should be like Q per A. U.
So just think of N as Q.
And it's just like, remember how we did this? And this was Q over L? That's the linear charge density of an object. So nu is Q over A. It is the areal charge density of an object. What that? Okay. What? I don't know, possibly. Anyways, so we have this proton right here, this little thing going in here. So we need to stop this on these two. Let's see. It has that velocity. We know if it has an electric field, we know that the sum of the forces is going to equal to MA. So we can say EQ is equal to MA. So we can figure out that EQ over M is going to equal A. And then we can say we want the velocity. This right here gives us our delta V. Well, actually, let's do this. We can call this one V0. We can call this one V final. And we know X. So A is equal to V squared minus V0 squared all over 2X. And that's our distance. So we can set those equal to each other. And if we do that, what does that give us? That tells us E, basically. So if we have this E, we plug that in. If this is Q, oh, actually, that's fine. We're supposed to find the amount of charge, the charge density. So basically, we're supposed to find nu. So then we can plug in nu for this, right? And then if you'll allow me to sort of use this space in the middle, then I will say we have our EQ over M is equal to V squared minus V0 squared all over 2X. So I can plug in nu Q over epsilon 0 M equals v squared minus v0 squared over 2x, and then we should be able to solve for nu. And that'll give us the charge per unit area. Yeah, question? Oh, okay. So the question is, where did this stuff come from? So what I did is I stopped and I wrote down all this given information. And I looked at it and I said, okay, what's going on? Oh, I'm slowing this down. So to me, first, I'm always going to try to use what system of analysis? Hopefully, we're always doing that now, but I'm going to try to use energy. I'm always going to try to use energy first, because energy, right, can do a lot of stuff that I don't have to worry about the process. But I can't really see how to do this with energy because we haven't talked about energy stored in electric fields and stuff like that yet, right? We've just talked about force and that sort of thing. So we have talked. So I can't use energy, but we have talked about force in electric fields, and I should remember that the force or the strength of an electric field is F over Q. In fact, some of you, your wrist will definitely remember that. Okay? So I remember from this, right, I get F is EQ, right? So I say EQ equals MA. You see that? Because what is happening, right, the result on this particle is there's some acceleration. So the sum of the forces on the particle is MA. What is the only force? The only force is FE, force of electric field, which is EQ right there. And so then I say EQ is MA. Yeah, I just said the sum of the forces on the object, right? And then once I did that, I said, aha, if I can get the acceleration of this thing, then I'm good. Well, look, I have the initial velocity, I have what has to be the final velocity, and then I know the distance. So using this equation, which comes from energy, so I guess we're using energy in some indirect method, we get v squared minus v0 squared over 2x. That's just, what is that, like the third equation in your formula sheet, something like that, under mechanics. So I take that and I set it equal to this, which was right here, right? And then I say, what is E for a capacitor? This, right? And we can remember from our discussion, Grant asked that interesting question, why was an infinite plane of charge? Why was the electric field N over 2 E0, right? Remember that? Right? That's because we have two planes, therefore it doubles, and we just get this. So I plug that in, boom. Yeah.
What's a 1 times 10 to the negative 4.4?
Oh, because that's the second half of this problem. They said if, I think part B or something, they said if you had this much charge density, what would happen? So as you can see, I'm just going to stick that back in where nu is, and then I can solve for nu. I can solve for a different V final.
How do you know that's your
Because they told me this was the initial velocity, and they said at anything higher than this speed, when that electron hits this plate, it's going to release X-rays, which is dangerous. So it has to be less than that speed, like that speed or less. So that's why I chose that as my final. So if we choose this one, we can calculate our new final speed. Any questions? I mean, if you were doing this in a lab, you would get exposed to them, but you wouldn't even know it. And then you would just keep doing it, and then you would cure yourself. Yeah, it's probably you would like start to get, depending on how you were testing and the environment, you probably start getting thyroid, little issues, hormonal issues out of whack. All right, any questions? All right.